Okay, everyone, are we back? Okay, and now welcome back, everyone. I would like to give the floor to Dr. Bashriya and Dr. Hafsa to lead the technical session. Dr. Bashriya and Dr. Hafsa, the floor is yours. Thank you.
Hello, everyone. 1 minute. Hello, assalamu alaikum.
Walaikum assalam.
Can
hear you and see you, Doctora.
Okay, so assalamu alaikum. Can you see me, Dr. Manar?
Yes, we can see you.
Okay, thank you, Dr. Iman, and good afternoon, everyone. Actually, it is a pleasure to be a member of the Women Research Committee. I'm Dr. Bashriya, an associate professor in the Sustainable and Renewable Energy Department, College of Engineering. I have been honored, me and my colleague Hafsa, to introduce the technical sessions prepared by our fantastic researchers in the science and technology. So now I will introduce our first technical session entitled by Solar PV, Soiling Mitigation Method of PV Modules under Desert Conditions, prepared by Hibatullah Al-Hamdani and Sheikh Al-Blushi. Hibatullah, just make brief for our presenters. Hibatullah Al-Hamdani started her career in Dubai Electricity and Water Authority in Quwa in 2014 as an outage planning and optimization engineer. Hibatullah joined the Solar Energy Research team at Quwa and Research Development Center. Her current research interests include solar PV performance and reliability in hot desert conditions, dust mitigations, and anti-soiling coating. Hibatullah holds a master's degree in data analytics from Prosser Institute of Technology and PhD degree in electrical engineering from the American University of Sharjah. Our second presenter or her mate in the technical sessions is Sheikh Al-Blushi. She's received the bachelor's degree in electronics and electrical engineering from Sharjah Higher College of Technology in 2013 and master's degree of professional studies. She is currently a researcher in Quwa and Research Development Center and then solar energy area. Our presenter, you have 25 minutes for your presentation, 20 minutes for the presentations and 5 minutes for the questions. The floors are yours.
Thank you for the introduction. Good afternoon, everyone. My name is Hibatullah Al-Hamadani. My colleague Sheikha and I are part of the solar research team at Quwa R&D Center. And our research interest is in PV performance and reliability. The main purpose of our presentation today is to provide a basic technical understanding of the cleaning methods for PV currently under study by the solar R&D team. First, let me briefly introduce you to our facility. R&D Center was established in 2014 and consists of 4 main research areas in the research: solar, water, energy efficiency, and smart grid integration. These areas are supported by the Industry 4.0 area, which includes robotics and drones, 3D printing and additive manufacturing, artificial intelligence and Internet of Things, and finally, advanced materials. And this in addition to the space technologies research. Our center is located in Mohammed bin Rashid Solar Park, the largest single-site solar park in the world based on the independent power producer model. It supports one of the 5 main pillars of Dubai Clean Energy Strategy 2050, which aims to provide 25% of Dubai's total power output from clean energy by 2030 and 75% by 2050. And our target is to reach a total plant production capacity of 5,000 megawatts by 2030. Our center includes state-of-the-art indoor solar PV testing labs. It consists of advanced electrical, mechanical, optical, and material characterization labs. We also have an outdoor solar PV testing facility and includes more than 30 solar panels of various technologies from global specialist manufacturers. It also includes other testing facility for concentrated solar power, building integrated photovoltaic, multi-tilt PV angle, single and 2-axis tracking systems. And the main purpose of the outdoor test facility is to study and evaluate the performance and reliability of solar panels under desert climatic conditions. So to begin with, to increase the production of the PV power, technological efforts are now being made not only to produce high-performance PV and reliable solar cells, but also to mitigate external factors that can reduce the conversion efficiency of the PV modules. And one of these factors is the soiling effect caused by the accumulation of dust on the surface of the module, which reduces the transparency of the PV cover glass over time and consequently decreases the production of PV energy. Now, humidity and temperature generally offer over a wide range in desert and semi-arid areas, such as the MENA region, which can result in wet surfaces in the morning due to dew and dry surfaces during the day. And we can anticipate that these regular humid and dry cycles can strengthen the cementation processes and increase particle adhesion, and so have a major influence on soiling. Cementation is the process where at high humidity, the solution of dust particles on the glass surface results in microscopic water droplets, which contains both dissolved salts and insoluble particles. And these droplets, they leave the particles glued to the surface in precipitated salt when they are dried. Our solar team here investigated the average daily soiling rate, and the results showed that the soiling rate could go as high as 0.7%. And so the awareness to reduce the dust adhesion to the surface and keep the PV panel clean has resulted in the development of soiling mitigation methods such as self-cleaning, by integrating a self-cleaning feature to the PV system. Now, this is achieved by altering the morphology of the PV module surface by introducing either a super hydrophobic surface or a super hydrophilic surface to create an anti-soiling effect. And these surfaces are classified based on how it interacts or sticks to the water droplets. Hydrophilic means it has a strong affinity to water, while hydrophilic means it has a strong affinity to water, while hydrophobic means it repels water. So a primary indicator that is used to classify these surfaces is the water contact angle measurement. And the surface contact angle is formed at the intersection between the liquid to solid and liquid to vapor interface. And the interaction between the solid and liquid is described by 2 forces, cohesion forces and adhesion forces. These are known as well as intermolecular forces. So the balance between the cohesive forces of similar molecules like liquid to liquid and the adhesive forces of different molecules like liquid to solid will determine the contact angle created at the liquid to solid interface. So if the angle is below 90 degrees, we say that the surface is hydrophilic. And if it is above 90 degrees, we consider it as hydrophobic, while if it's above 150 degrees, we consider it as super hydrophobic. So in other words, if the water droplet has a tendency to stick to itself more than it sticks to the given surface, we call that surface hydrophobic, and eventually the water drop will bead up, would create a full water droplet, and it will have a contact angle greater than 90 degrees. Conversely, if the water drop tends to stick to a given surface, then it's more than it sticks to itself, more like water spreading. That surface is considered hydrophilic, and it will have a contact angle below 90 degrees. Now, from this understanding, if we create such a surface or form a thin layer of this coating on a PV module surface, if we create a super hydrophilic surface, how it will react? The water droplet will basically go beneath the dust or the contaminants and wash it away. Whereas on a super hydrophobic surface, the water is repelled from the surface, creates a full water droplet, and it will roll off the surface, taking the dust particles with them. Now, another property that characterizes the hydrophobicity is the contact angle hysteresis and the surface roughness. The contact angle is the difference between the advancing and receding contact angle of a water drop on a tilted surface. So basically it describes the surface adhesion. If the advanced angle is greater than the receding angle, this indicates a weak surface adhesion, and if the water droplet will slide down the inclined platform. But on the other hand, if the advanced is lower than the receding angle, it will result in the droplet being unable to slide down the inclined platform. And both the water contact angle and the hysteresis are caused by the surface heterogeneity and surface roughness. The surface roughness can also be classified into either micro or nanoscale roughness, and both help to increase the water contact angle. Now that we understood the basic concept of anti-soiling coating, to evaluate and understand the performance of these coatings in desert conditions, in collaboration with NREL and Indian Institute of Technology, DIWA performed a study to investigate the effectiveness of anti-soiling coatings along with other cleaning procedures. And this was achieved by mounting coated glass coupon samples on a black backplane in custom mounting racks to achieve a temperature similar to the PV module. The specimens were weathered for 1 year, and a set of manual cleaning practices were performed to study the effect of abrasion or scratches and provide insights regarding the soiling and effectiveness of cleaning. So separate tracks were either not cleaned or cleaned with a hog bristle brush or with a low pressure water spray, and finally a wet sponge. The cleaning was repeated once every month, and the analysis of contamination was achieved using an area measurement software in which it manually extracts and measures the area occupied by contamination, which resulted in a parameter we call the percentage area coverage. So as you can see from the graph, the wet sponge cleaning technique resulted in the lowest percentage area coverage compared to the dry brush and water spray. And for the wet sponge, the coupons that were coated not only with the anti-soiling coating, but as well with the anti-reflective coating, it showed much better performance than without anti-reflective coatings. And on the other hand, the dry brush cleaning led to significant damage for most of the samples. Now looking at the microscopy images, if we look at sample D, the anti-soiling coating was completely removed after 1 year of dry brush cleaning, whereas for the wet sponge technique, the abrasion was significantly less. And much of the abrasion in sample A may have resulted from the accumulation of soiling between the cleaning events. So you can say that we either have a higher frequency of dry brush cleaning to limit the accumulation of contamination between the cleanings, while putting in mind that we need to extend the lifetime of the coating, or another option is to use a more abrasion resistance coating for dry brush cleaning as shown in sample C. And if we look at sample B, it had much less abrasion. So here we can conclude that we need to consider both the environment and cleaning procedures when developing new anti-soiling coatings. I'll leave the floor now to Sheikh Abed to discuss another method under study, currently under study by us, which is the mechanical cleaning method. Thank you.
Thank you so much, Heba. Another practice cleaning approach is the mechanical PV cleaning. This approach includes manual cleaning, hydraulic cleaning, and robotics cleaning. Manual cleaning is the traditional.
Sheikha, I think you were muted by mistake.
Yes, please. Hey, Sheikh. Sheikha, can you please unmute yourself?
Okay,
Thank you.
so I'll start from the beginning.
Yes, please.
Okay, another practice cleaning approach is the mechanical cleaning, PV cleaning. This approach includes manual cleaning, hydraulic cleaning, and robotics cleaning. The manual cleaning is the traditional method to remove the dust settlement on the panel surface using cleaning tools. This cleaning procedure is performed by wiping the dust using a brush and water in addition to chemical substances if needed. Although this method is effective to remove hard dust or hard dirt such as bare rubbing, it also has some major drawbacks. It is time-consuming, especially in large-scale PV panel PV plants, and in addition, it requires manpower, which can be costly. Furthermore, the risk of PV panel surface damage is high with manual cleaning because it can lead to PV glass abrasion and even cracks if the cleaning was not performed properly. So in order to avoid the drawbacks of manual cleaning, water cleaning is another widely used cleaning method. Water cleaning reduces the potential of abrasive damage as no panel brushing is performed during the cleaning procedure. The cleaning mechanism is based on installing hydraulic sprinkles that deposit water on PV panel surface in order to wash it. Now, the main issue with this method in desert region is the scarcity of water resources, and this method does include using high amounts of water. And another challenge with hydraulic cleaning in desert is the fact that the PV panel surface temperature can rise to as high as 70 degrees Celsius during the day, which introduce the risk of thermal shock on PV glass due to a difference in water temperature and glass temperature, which can lead to cracks on the PV surface. So based on the major drawbacks of the two previous cleaning methods, the current research trend is focusing on robotics cleaning. In a review on different PV cleaning mechanisms, where a comparison between the numbers of publications under each cleaning method was conducted, it was found that the highest number of publications between 2009 and 2017 was under cleaning robotics, among other techniques, with a total number of 9,423 original research articles. Accordingly, that indicates that researchers are more positive about the robotic cleaning approach more than the other cleaning techniques. The robotic cleaning approach or method can be classified to under three categories: vehicle-mounted system, semi-automated systems, and fully automated systems. The vehicle-mounted PV cleaning system, as shown in the first picture, consists of an arm attached to the vehicle. The end of the arm has an unattached brush. The vehicle is driven by a trained operator between PV arrays to perform the cleaning. Each machine has its own system for controlling the pressure of the brushes on the PV modules in order to avoid any PV module damage. The pressure limit on the top of the PV module must be within the tolerance allowed by the module manufacturer. The vehicle-mounted devices are associated with a higher risk of PV module damage because irregular ground conditions may cause the brushes to exert a higher pressure on the PV module, which can lead to PV module crack or even breakage. The semi-automated and fully automated robots are almost identical in concept as they share the same main technical features. They both consist of a brush, the robot body, power supply, control and communication system, and in some cases, water feeding, sourcing, or storing source. The difference is that the semi-automated robot requires two workers to move the device from one PV row to another, After that, the pre-programmed cleaning procedure happens automatically. While with the fully automated systems, they are installed on each row of the PV plant, and they are stored in at a docking or a parking station at one side when there are no cleaning procedures going. So therefore, there are no labor needed for the positioning of the device. And also, in addition, the fully automated devices may have an additional rail system installed to support the movement of the robot along the PV row, especially in a frameless PV installation. So with that being said, it is given that less manpower is needed for robotics cleaning in general, and the cleaning procedure can be performed in significantly reduced time. This makes robotics cleaning an attractive cleaning approach in desert climate. In fact, there are multiple companies that are targeting desert region market by working on developing a water-free robotics cleaning system. However, at the end of the day, the cleaning robot is an electronic device that is prone to failure while performing in such hot and harsh weather conditions. And moreover, there is also the challenge of effective dust removal with minimum damage to the PV panel surface. And this is where our role as an R&D center comes. In order to address the previous challenges, we are currently conducting a study to investigate robotic cleaning approach under the harsh weather condition of Dubai Desert. The study started with evaluation for all commercially available cleaning solutions. And then we have selected 4 robotics cleaning solutions to be tested and evaluated based on their performance, durability, and efficiency under desert condition for at least 1 year. After that, we will be able to identify the areas of improvement and come up with the final recommendation based on the result of this study. And the final outcome that we will be able to develop a novel robotic cleaning system that can withstand the harsh desert climate conditions. Thank you so much for your time. And if you have any questions, you can ask us.
Thank you so much, Hibatullah and Sheikha. Thank you so much for impressive technical sessions. So the floor for the audience, please, if you have any questions, we are happy to listen to it. I will start by first questions, if you don't mind, until the audience start. So you are talking about the solar PV and the cleaning of it. If you have talk about 3 methods, which is vehicle system, semi and fully system. In terms of cost and efficiency, which one is more efficient? Sheikha, I don't hear you. Please unmute yourself.
Yes, you mean for the robotics cleaning? Yeah. The cost for the robotics cleaning systems depends on various concepts or aspects because the design of the robot, the maintenance, the operation. So each one of them, when we reviewed the market, there was big difference between the prices. So I would say it doesn't matter, or it doesn't depend on the type rather than the technology used and the company that providing a new technology or a novel invention to the market.
If I ask regarding the cost or the efficiency for the cleaning, I mean, which one is more? I mean, for the working, all of them, they have the same, or you said you know no worries about the cost. So for the efficiency, have you make something like that for the study?
No, currently we have selected 4 companies to be tested, and after we finish the study, we will, the results will decide or will recommend the best in efficiency and performance, and also durability and withstanding, being able to withstand the desert condition, the hot and the harsh weather condition. I can't hear you. I'm muted.
Thank you so much, Sheikha and Hibatullah, for your presentations. If any questions, still we have a time, our audience.
This is very impressive, Sheikha and Hiba. Especially, I looked at your age. You look so young. Is this an ongoing research project? And I'm just exploring, because this is really huge efforts. How long it takes you, and is it still ongoing? What do you do? Like, do you publish these results in a research paper at DIWA Center, or how you share these outcomes so that you make sure it is community benefit? I can see this is a great potential for UAE that we can benefit. So I'm just wondering how that would be shared. Is it publication? Is it that you talk to some organizations? And is it it has real application in real environment? I would love to see this, and I'm sure the audience, they have the same questions like this one.
Yes, the projects are ongoing, so the results are not finalized. And once there are several, for example, for the anti-swelling coatings, we have future plans. Our main ultimate goal is to, in the end, to develop customized anti-swelling coatings for desert regions. So at the moment, we're testing or evaluating different anti-swelling coatings, studying its performance in desert conditions, and then eventually be able to develop specifications that would be, to develop coatings that would be suitable for the United Arab Emirates. Since the anti-soiling coating and the robotic cleaning is ongoing, we definitely will share our results once we conclude and study the efficiency, the cost, the benefits of certain types of anti-soiling coatings, or the best type of cleaning method. It will be shared with the research community. It will be we can provide recommendations to the IPP, independent power producers. So there is a plan as well to publish our results in the future.
Thank you, Hibatullah. I have some questions here in the chat. We have a questions here from, it says that, how about joining BV cleaning together with a hydroponic coating process in one process during robotic cleaning? Is there a company doing this?
Actually, part of our project is to test anti-soiling coatings in combination with other cleaning methods. So we know that the anti-soiling coatings reduce the dust accumulation, or the advantage of the coatings is to reduce the cleaning frequency intervals. But our hypothesis, or what we're trying to look into, is the anti-soiling coating efficient on its own to reduce dust accumulation, or it should be combined with another robotic cleaning method. So this is one of the things that we're looking into at the moment.
That's so impressive. Another questions here, we said, what are the super hydroponic surface coating which are mentioned as polymers? So do you have the name of it, please? Moza, sorry. Hiba, you hear me?
Yes, can you repeat the question, please?
Yes, the question is, what are the super hydroponic surface coating which are mentioned as polymers?
There are several super hydrophobic surfaces. There are materials that, for example, we have titanium dioxide, which is widely used at the moment, and in combination with nanoparticles, we can convert it into super hydrophobic surfaces. We also have, so we have zinc oxide, we have silica, we have these are the mainly used. We have titanium dioxide in combination with nanotechnology. So these are some of the common materials that are used currently for commercial anti-soiling coatings.
Using nanoparticles is not going to reduce the efficiency of the PV cell, or it have been taken into account this part?
Nanoparticles are taken into account when combined with titanium dioxide particles, for instance, to balance between the surface roughness and the transmittance of the material. So in fact, it should improve this. These are applied on the PV cover class. So we're expecting that it should improve the efficiency of the solar panel and at the same time reduce the dust accumulation on the surface.
Thank you so much, Hibatullah and Sheikha. Actually, it's very impressive presentation, and it's a very good work for the community. It's very useful one. Thank you so much for your presentation, and I'm going now to start the second presentation. Thank you.
Thank you very much.
Your work. So now our second presentations, also from a researcher from the DIWA, entitled Dimensional Accuracy of Additively Manufacturing Metal Parts Infused Filament Fabrications Process, prepared by Moza Yamahi and Tawaddud Al-Kendi. Moza Yamahi is currently a researcher engineer in Dubai Electricity Water Authority DIWA. She received the bachelor degree in mechanical engineering from the United Arab Emirates University, Al Ain, in 2018, and she's earned a diploma in the principle and applications of digital fabrication offered by Global Fab Academy in 2019. She's passionate about three-dimensional design and manufacturing process, especially additive manufacturing technology, which is her research interest and field of specializations. Tawaddud Al-Kendi received her master's degree in material science and engineering from the Master Institute of Science and Technology in Abu Dhabi in 2019. She is currently working at DIWA, Electricity and Water Authority, and the Research and Department Center as a researcher in the advanced material and energy storage. She has several publications related to the advanced material synthesis characterizations and additive manufacturing, as well as the energy storage application. Moza and Tawaddud, the floor is yours.
Assalamu alaikum. Good morning, everyone.
Alaikum salam.
The voice is clear.
Yes, it's clear. Go ahead.
I am very thrilled and happy to be among you here today. And thank you very much for attending today's technical session. My name is Tawaddud Al-Kendi. And today we are going to present our investigation work related to additive manufacturing of metal parts that were printed at DIWA's R&D Center. The exploration of additive manufacturing field is very crucial since it contributes to the fourth industrial revolution industry. Not only that, it is also a technique that enables the user to create bespoke designs with various geometrical and specifications and various shapes and materials to serve different purposes. In today's presentation, we will give you an overview about the 3D printing lab at DIWA's R&D Center. We will give you a very brief introduction about what is additive manufacturing and its applications and the techniques used. We will also go through the motivation and the methodology behind our work. The 3D printing lab at DIWA's R&D Center is equipped with huge capabilities of printers. So some of the examples of the printers that we have at our labs is the Metal X. The Metal X printer, it enables the user to print using metal materials such as copper and the stainless steel. However, the Ultimaker S5 and the Raise Pro Plus is specified for printing plastics materials. The Markforged 7 is dedicated to printing composite materials such as onyx. And finally, the WASP 6100 is specifically used to print with plastics and clay materials. Let's talk and explain a little bit about additive manufacturing and what is really this technique is. So the additive manufacturing method is defined as a technique that joins materials layer by layer to create a 3D object from CAD data. You can see this method illustrated in figure A. As opposed to other manufacturing methods that is also known as subtractive manufacturing methods. The subtractive manufacturing method is the conventional manufacturing technique. And in this technique, a material is removed from a solid block until the final object is created. So the main benefit of additive manufacturing that it saves a lot of waste material. There are also other benefits that makes the additive manufacturing technique a very promising method to be followed. And there are two other main advantages for this type of manufacturing. The first method is it enables the user to create near-net shapes objects from an existing parts. So, for example, here at DIWA's R&D Center, we work on 3D printing to serve other business units such as distribution power and transmission power, where we print critical components that they use in their stations to serve their purposes. These figures show pictures shows the original parts and the printed parts. The parts on the left side represents the original parts that we reprinted, and the pictures on the right side represents the objects that we printed at our labs. The second benefit of additive manufacturing is related to the cost. As you can see from this diagram, that at low volume production, the additive manufacturing method offers a low cost in comparison with the conventional manufacturing methods. Even though the diagram shows that at higher volume production, the cost becomes more expensive in comparison with the conventional manufacturing methods, but this does not sustain for a long range of complexity. This diagram explains this point better. So the additive manufacturing, the conventional manufacturing techniques would provide a less cost at higher volume production, but only until a certain limit of complexity. When the complexity of the design reached to a specific limit, the cost of the parts will increase. And here where the additive manufacturing technique kicks in with providing a lower price for the volume in comparison with the conventional method. So there are several additive manufacturing techniques, and some of the most important ones are the binder jetting and the stereolithography, as well as the fused filament fabrication and material jetting. However, in our work, we have focused on the fused filament fabrication method. Now, my colleague Moza Yamahi will continue, and she will explain why we have chosen, how we have chosen the best methods that suits our application.
Thank you, Tawaddud. So different additive manufacturing process or techniques provide us with different or contains different detailed mechanism. And with these differences between each additive manufacturing technique, the dimensional accuracy got affected. The dimensional accuracy, if we would like to define it, is it refers to the CAD model or the original CAD design that we have matched with the 3D printed dimension that we already produced. So how much they are similar and how much they are different from each other. And the dimensional accuracy actually it got affected by also different factors, which are printing parameters in each additive manufacturing techniques. We faced, or we need to consider number of printing parameters. So due to those differences, such as the material type of material, we got different dimensional accuracy, as each material have different behavior. So in spare parts application, the dimensional accuracy is a critical point that we need to consider. And here we need to select the most accurate additive manufacturing process that will be suitable or will fill our requirements. We did many research, and we found that in producing spare parts application using fused deposition modeling is a recently new comparing to 3D printing plastic material. So because this process is printing metal using this process is new, recently new, there is a lack of knowledge in dimensional accuracy, and not only that, but also there is no standard test design that can evaluate our 3D printed parts, metal parts. So from here we got the motivation to test the dimensional accuracy for especially metal parts produced by FFF technique, and also develop a new test design that is customized and that can be a standard for our spare parts application. So our methodology started with 3D designing the model in Fusion 360. Then we 3D print the part, then 3D scan it, and finally do the data analysis for the results we got from the 3D scanning data. Starting with the 3D design, we develop a certain features in our part that they are common used in spare parts applications, such as shaft feature, holes, as well as linear dimensions that are used in the spare parts application. So we try to cover as much as feature that can be used in spare parts application. So this design will be a reference for us in the future if we would like to print with the certain type of material, metal part materials. And those are examples of the 3D part that we print. Starting from the left, we have copper sample, then stainless steel, and the last one is onyx material, which is a type of nylon based, and we used as a reference because as we said that the metal parts are the dimension accuracy for metal parts are recently, or a new technology that is recently added to the technology. So we keep the plastic as a reference, and we print from each material 6 samples, and to have accurate results. So as we said, in this research, we use a fused deposition modeling technique to produce our 3D printed parts. And for metal parts, the part goes through 3 phases, starting with 3D printing, then washing and drying phase, and finally the sintering, where the part got the mechanical properties and be ready as a metal part. However, for composite FFF 3D printed part, the part only goes through only one process, which is 3D printing, and no need for post-processing after the printing. So copper material and stainless steel material, they were printed through 3 phases. Next is 3D scanning. In this stage, we used advanced 3D scanner, which is called hexagon 3D scanner, to scan the object and merge the scanned data with the CAD original file that we have already developed, to get the difference in the dimensions between the original CAD and the existed one, or the printed part. So we got the results from the scanning data. As we can see here, we have a 3D map, 3D colored map. This gives us an indication how the part is different than the original one. So the green color gives the green color indicates that the feature is within the tolerance limit, which is good. However, the yellow color gives us the indication that this feature or this geometry is oversized than the original CAD. In addition to the blue color is giving indication that the feature is undersized. So we can see that most of the copper part is approximately green. Stainless is approximately green, and there is a little or in certain area there is yellow color, and for onyx material there is we can see that most of the features they have blue color. So what we did is we took each feature in our design, and we measured the dimensions exactly for each one, for the six samples from each material. Then we took the average to know how it's different than the CAD size. To conclude, in our work, we evaluate the dimensional accuracy for metal FFF process, and we achieved average dimensional deviation less than 2%. And also we were able to develop a new 3D design to evaluate metal 3D printing samples using fused deposition modeling technique. For more details,